Very good afternoon to everyone. My name is Bhargav HK, Program Lead Bytes. I would like to welcome today's expert, Sreehari Ramashetty, Cloud Architect, TCS Bengaluru. I would like to welcome all the participants to Bytes Expert Series. Today's topic is cloud computing. I would like to introduce today's expert, Sreehari R. Srihari R is an expert in enterprise cloud architect and database architect roles in TCS with responsibility in cloud platform development. He has 24 plus years of experience and has been with TCS for 21 years. Sir, once again I welcome you. I request Srihari sir to continue the session.
Thank you very much, Bhargav. Thanks for a nice introduction. Hi, as Bhargav mentioned, my name is Sreehari, and I've been associated with TCS for the past 21 years. Majorly, I've been working as a database architect and cloud architect. So I've been involved in a lot of implementations in the cloud platform, be it in the private cloud or the public cloud. So to start with, we would like to talk about today's session on cloud computing. So I hope I'm not too fast. If there is any problem, please let me know. I will try to reduce my whatever the speed with which I am talking about. So what is cloud computing? Basically, you have your desktop, okay, and you have your computer or you have your device, and you have a set of in your device you have something called a server which composites of computer sorry um, a monitor. Then you have CPU, RAM, storage, and all. So what do you mean by computing? Computing is something is a logical term where we usually use in terms of mathematics like multiplication, addition, subtraction, and all. So how does this computer actually does this algorithm or does this computing? And how do you when you pass some command, say multiply x into y, how does that x into y gets translated into your readable format? So cloud computing is basically a practice, or you can also say a demand availability of the computer system resources, especially in terms of storage. Then in terms of power, this power when I talk about SMPS, like electric supply to the system, and also the management of the environment. So when we say management of the environments, we are talking in today's world. We talk about large industries where they are talking about a lot of computing power of large scalable scales in terms of petabytes of storage, in terms of thousands of servers, in terms of terabytes of memory, GB memory, RAM. Okay, so all these things. How do you manage basically? How do you manage? How do we actually compute in terms of the cloud computing power? The cloud computing is nothing like a practice or you can call it as a set of services or hosting services in a single place. So it can be a data center, it can be a room, it can be an entire building, which composites of a network between all the servers. So in a very broad perspective, these services are categorized in terms of infrastructure as a service, then in terms of platform as a service, in terms of software as a service. So we'll talk about all these services down the line in a bit brief way. So I just wanted to just give you a very high level view of what actually a cloud computing means. So according to a definition, according to wiki definition, we can see that cloud computing is an on-demand availability. When you say on-demand, an industry or in a company or in an organization, so they want to enlarge, enhance their businesses, and they want to store their data in terms of storage. And where do you get the storage? So that is a demand. You need more storage. So how do you get? So anything that happens automatically in a very autonomous way, so that is called on-demand. So that on-demand computing of resources in terms of storage and power is something called cloud computing. Okay, so what are the benefits of having such a cloud computing? So here, cloud computing basically offers a lot of business benefits, such as agility, speed to market, efficiency, scalability, cost savings, collaboration, mobility, and security. So when you talk about agility, so agility, what is agility? So in terms of, I have a requirement from a business, okay, and my business says I need to develop some application overnight, and you if, in a traditional way, if any new application program is been designed in an organization, and they have to, a set of people gather in a conference room and say, come sit along, and they'll design. So how many cores of CPU you want, how much of RAM is needed, how many servers you needed. So here, for that traditional process, it's a very time expensive. Basically, you first sit and design on paper, then you have to procure from an outside market, go to the market, bring it, and then it takes more than so for some cases it takes a week. It may take a month, or it may take a year also. It depends on how large the scale of your requirement is. So here in cloud computing, when you say cloud is something like it's a platform, or basically it's an environment where you already have hosted services built on top of it, and then all you need is an end user or a user or a business user just uh, accesses the cloud environment, and just whatever he wants to build, he'll build on the fly. So that is called agility. Now, speed to market. When I say speed to market, is also something like you basically build some services for your business requirement, and you have to send it to the market to be consumed by the consumer. So how fast can you do? There are some, for example, let's take an automotive industry, or let's take any product in terms of credit cards, or in terms of any consumers perishable goods or non-perishable goods, or cookers or fridge, refrigerators, anything. So you have a new design. There is a study happened from a consumer side, and consumer side we need some sort of a equipment on so and so requirement. Now the manufacturing has been done, but who will put it to the market at what pace? So how do you actually publish this? So in terms of we are talking about in terms of the software technologies. So how fast you can build the product and put it into the send it to the market to sell it. So that is what the speed to the market. So in cloud technology, when the moment you have acquired the resources, you develop the product on the fly. It's more on agile. It's more on a DevOps perspective, agility, and then you probably will put the product into marketplace. Then efficiency. So efficiency is how best you are using the resources, consuming the resources of the cloud, and what way and how efficiently, how cost benefited you're trying to consume the resources. For example, I spoke about the traditional costing. So for traditional costing, you are spending more man hours, you are spending more for a single product. You have to go to the market, get it, buy it, and you are spending all the cost involved, transportation costs, then labor costs, then man hours, everything. So but in here, you already, the cloud has already consumed most of this readily available product into the in its cloud, and all you need is identify what resource or what type of server is needed, or what type of compute power is needed for your application. So for example, you design an application, and you go to the market. You go to the producer and say, I need a server of 100 terabyte of data with 32 GB of RAM. But your application doesn't need that capacity. You are unnecessarily bringing in that sort of power into your on-premise or into your store, and you are keeping most of the unused power. So how best you are using the cloud? So how best you're using the cloud management? How best you're using the cloud computing with an efficient way? So that is called efficiency. Then scalable. So we all know what is scalability. So I have procured for 100 GB. I had procured for 100 terabyte of storage. I have procured for the 50 GB, 56 or 32 GB of RAM. But now there is a lot of demand for my product or for my business in the market, and I am growing. So usually, whenever we design a capacity planning, there is something called capacity planning. Whenever we design, we basically take a year growth, or a 2 years growth, or a 5 year growth. But unfortunately, as anti even if you are not anticipated such a business growth, suddenly your business it's been like, it's been a Christmas time, or it's a Diwali time, or Dasara time, your business grew up. then your data, the data gets on pumping, your data gets on pumping into your system, and your system are not have come to an isolation, or sorry, have come to an uh, uh, what do you say, capacity, end of capacity, where you are already reaching your 100 terabyte what you procure. Now, how do you scale up? So you have to again go back to the traditional way. You have to again wait for a month or two to get whatever you have procured, whatever is sent your procurement request to a additional storage. But in cloud, it is not that. The additional storage is already being procured by the cloud sorry, excuse me, already provided by the provisioner, and all you have to do is send him a simple request to enhance, to add more capacity. Or in public clouds, even as an end user, you have the capacity to add yourself the additional capacity needed. And there are a lot of automations which also happen as part of the public cloud capacities, where you can design in such a way, or you can automate the process whenever there is a endpoint as acquired, like your storage has come to a point where it is already reaching its maximum, then automatically additional storage, or 100 GB, or 10 to 1 GB, 10 GB, 1 terabyte, whatever capacity you would design is as per your automation will be added. Or there are two types of scalability basically. One is the horizontal scalability, and one is the vertical scalability. So when I say of horizontal scalability, for example, you have a server, you have deployed your applications on a server, which is say 32 GB RAM and 1 terabyte or 10 terabyte of capacity. So now you reached your maximum capacity, and you are enabled for horizontal scalability. So what will happen in the horizontal scalability? It adds another set of same capacity servers, and it gets linked, replicated. All your data gets replicated, and you start to use your another set of servers with the same capacity. That is called horizontal capacity scalability. And what do you mean by vertical scalability? Is you actually uh, add more resource to the existing server. For example, as I said, 32 GB and 10 terabyte, you want to enhance to 126 GB of RAM, and another 10 terabyte of your storage, then that will be added to the existing system, or existing host, or existing virtualization layer. So that is how is scalability. So am I being too fast? Are you guys able to get me? If there is anything, please you can stop me in between. Okay. So
Yes.
yeah. So the next point is on cost savings. So there is a version of difference between your own data center. Your own data center basically works on a capex model. So where you do an initial capital investment on your procurement, whereas on a public cloud, you go on an opex model, where you're bearing the operational cost. That means, to whatever, let's say you have a requirement of 100 servers, but in private cloud, for you, what you do is you actually buy 150 servers to keep another 50 servers as buffer. So that 50 servers is an additional cost which you already paid to buy it as a capital investment. But in a private cloud, in a public cloud, this extra 50 servers is what you don't need have to buy in, even at the very initial moment. As and when we just spoke about scalability, right? As and when you require, you can just scale it up, and you can increase your capacity. So this is more like the payment model will be more like an pay as you go. I mean, pay as you go in the sense, whatever you procure and use it at that point of time, only it will be charged. So it is not an already invested product. You're not investing anything in advance. So there you can see the cost savings in terms of, because cloud mostly works on virtualization. So this virtualization is something where you have a physical server. There are you can even call it as a bare metal, and you have a server basically, which is a physical host. On top of it, they have some this physical host obviously comes with memory, RAM, CPU power, and everything. Based on that, you on the memory, you try to do a virtualization. There is a virtualization software installed, like VMware vSphere, and other products. Okay, so this way, for example, if I talk about VMware vSphere basically it's an hypervisor. So hypervisor is something, it's a software defined service. Okay, where it actually takes your memory and your storage as a virtualization, as a virtual environment, and builds a number of virtual machines, which actually looks to you like you are working on a physical machine itself, but internally it is not a physical machine, it's a virtualized layer. So what I do is, instead of in a traditional way, what we used to do is, earlier, before this virtualization cloud concepts came into the market, came into the existence, uh, most of these consumers, they used to, for every single application or single environment, single database, they started procuring individual boxes. Now that element of cost is eliminated, basically. Why? Because in a single server with that capacity, I can build multiple environments where I can distinguish, I can make it as a tenant, multi-tenant environment. But it will be working like you, like a single tenant, where you are still the owner of that particular virtual machine, and it is not shared with any other virtual machine. So you still can implement a number of applications, in a number of components, software components, applications, databases, anything. But they don't interact each other unless you enable a connectivity. That's a different question. But still, they still act as independent. At the end of the day, you bought a server for X dollar, and you implemented the VMware vSphere or whatever the virtualization software, which it may cost another plus $1 or something, and then this is the operating cost for you. But if you go in the traditional way, if you want another application to be deployed, you need to buy another box. So by that, you're obviously consolidating your environment into a small, and that is how you actually do a cost savings. So in today's world, there is something called financial operations word, which is very vastly used in the industry, which is called FinOps. So this FinOps actually is doing the cost, most of the discusses most of the cost savings on how you actually can maintain the servers and the utilization of the uh, utilization of your boxes, or utilization of your servers and your products. Coming to the next is increased collaboration. What is increased collaboration? So, in a traditional way, I have to wait for my DevOps team or the developer team to come in. Then he has to write the code. There is some sort of a business requirement. Some modifications has to happen. He has to come, and unless he does his testing and something has to put in, it's a time. It's a sequential process. But here, it's more of a parallel collaboration, where you are an end consumer, you are still using the system, and you have a requirement, you can pull in the developer to parallelly work on your system, and apply the changes, or apply the ideas, or whatever. So that is more of an that sort of collaboration can be achieved only in mostly in the cloud computing area. No, mobility is something. It's not, when you say mobility. Okay, can we use mobile apps? Yes, mobility can also be part of a mobile apps or any other portable apps. But it's not only using of mobile devices, but also it's more into you can cloud computing can be integrated into, along with an on-premise private cloud, or along with an hybrid cloud. There is something called hybrid cloud, where you can integrate the systems on your on-premise or on your own data center with the public cloud environment. So that is called mobility. And obviously, security is one of the largest concerns. And even today, despite being a cloud market being there for almost 10-15 years, security is one of the biggest concerns, because your data plays a vital role, and securing your data is very important. So cloud comes with a lot of compliances and regulatory bodies from the government organizations, like SOX compliance, GDPR, and many ISO standards, which help ITAR, non-ITAR. So all these things, they play a very crucial role in the security in terms of internet connectivities, in terms of accessibility to the system from for the end user and the developers, communities, everything. So we have something called IAM roles, identity access management, which plays a very crucial role. So these are some of the very brief cloud computing benefits. Anyone has any questions till now, or shall I go further?
Dear participants, kindly post your questions in chat window.
Okay, okay, fine. Anyhow, we'll take at the end of the session if
Okay,
there
okay,
is.
sir. Please
Yeah,
continue, sir.
yeah. Thank you. So going to the next. Okay, so see, we are talking so much about the benefits. We are talking about cloud. We are talking about what benefits it can give. We spoke in very much about the futures of cloud benefits. We can't take it anything easy, right? So still we have a lot of challenges in terms of deploying your environments into the cloud. So, what type of challenges do you see? We already spoke about security being one of the major criteria, and one of the, though it's a benefit we can say, but still there are a lot of things which cloud providers, clouds has to come up with a lot of security features. Where such as I was talking about SSL layers, we are talking about internet security socket layers, where they even the SSL1 and other have, what do you call, secure layers were hacked earlier, so they have to come up with the new versions, and they have to come up with more point 0.2 version, 1.2, 1.52 dot version like that. So what features they would have enabled? So they were, for example, you are trying to access from your remote computer into a cloud, and you are trying to pull data. So there is something called a transit, data in transit. So when the data in transit happens, anybody can log in, or anybody can hack into your network area and try to pull out the data. So how do you prevent that? So that is what they have, something called SSL layer, security socket layers, which actually what do you say, which actually provides some sort of a security, or some sort of a layer which doesn't allow any other external users to log in or to see the data. Then data gravity, again we spoke about the same. Data gravity and security, they go hand in hand, because you need to understand what type of data are you pulling, what is the sensitivity of the data. So for example, we have our Aadhaar card, or in US if you go with SSN numbers or SIN numbers. So how much sensitive is that? It is it's a very PII information. It's more of a PII information. So whether we can really pull those information, personal identification information, or not. So all these challenges are very high. How do you control those challenges? Then regulations. I spoke about some regulatory bodies such as GDPR, Sarbanes-Oxley, SAC. It's called SOX. It's mostly used in US and some of the European countries. GDPR is vast only for European countries. Then we have ITAR, non-ITAR, which is also again US based. And then we have international standard ISO used worldwide. Then Australia has its own compliance regulations for each of their country. They have their own compliance. So what do these regulations actually, regulatory bodies actually pass on is, they are trying to send a control, send some information. They're trying to give you an idea on how you should actually control your data, in terms of allowing multiple user access, denying access to a lot of users, give access to only people who are recognized by your organization, who has, like for example, a developer can't access the production system, or a DBA can access only to certain elements to the database background databases. So even the application user, even an end user, can only see, read the data, but he can't update the data. So all these regulations are very much provided by these regulatory bodies. So they try to protect you from a lot of hacking, a lot of data loss, which also means a loss to your business, which also means loss of money, right? And again, regulations and compliance, they go hand in hand. So compliance is what I was talking about. For example, the SOX. When I talk about SOX compliance rules, they have something called GSD 332, which actually is a compliance rule given, which has to be put on databases. So whoever access databases has to be monitored regularly, and what type of access should be given, what type of database personnel who access the environment. So, for example, if an application user who can read the data should be only given the read access, and if there is any PIA information where the application wants to see, that has to be masked. So the mask data masking and all should be taken care. So all these compliances are part of those regulations. Now, again, coming to skills is a very niche. Basically, you especially in the public clouds, acquiring public cloud skill is very important. So when you're working on those public cloud environments, it can be hyperscalers like AWS, Azure, GCP. There are a lot of other IBM clouds and other providers. So you need to be skilled in those technologies which these guys are built on, which those clouds are built on. So that skill set is not that vastly available in the market. So you need to be very skilled in order to work on. So because most of these clouds are built in a very automated way. So for you are an end user, but you want to you are a developer. Basically, I can call you as an end user. You want to develop something, but if you want a server or a VM to be procured, so traditionally what will happen is you have to request the server services team who maintains the servers, who maintains the OS level OSs and servers. So they have to you have to take the permission, then the budget has to be passed on. But in case of this private cloud, sorry, public cloud, you don't need that. There is something called self-care portal where you will be given an access, and there is an identity IAM rules, the roles and responsibilities being as published, and the basically the owner of that particular account into that public cloud will actually maintain he will have the guidance, or he will try to maintain what type of role should be given to what type of developer or what type of user. So in that case, if a developer wants a immediate server to be procured for his development, so he can directly go to a self-care portal, and then he can click on to procure an instance, to procure a virtual machine with its own capacity, and that starts get working. But in that, as I said, in the traditional normal data center, it was a time consuming. If you require some new capacity, you need to wait for months together. So that is one. Then legacy applications is one of the major concerns in today's challenges in today's cloud. So not all providers have the capacity to convert the legacy systems such as mainframes or cakes or COBOL into the distributed systems on the cloud. So most of the cloud they are enabled on LUW, like Linux, Unix, Windows, and the mainframes is a totally different subject. So how do and mainframes are very costly, and most of the bankers in US and other European countries, they have mainframes as their you can say unit of work. And now with cloud, with all these hyperscalers coming into the market and claiming that they can give better business, they can do at very cheap cost. Now how do these legacy applications get converted? The entire banking industry in the US is entirely dependent on mainframes. Now, how do they move that? So it has been a very tough job. Till now, they were none of the banks which we are aware are not fully moved into the public clouds. Okay, there may be some newly developed applications they have tried to deploy it under the public cloud, but not the legacy applications. Okay, so that is one concern. And then obviously latency. So when we talk about latency, is between the connectivity between the end user and the cloud provider and their locations. So when we talk about providers, they have their environments in multiple locations across the globe. And for example, you are sitting in India, and you want to access a server in America or Europe or Australia. So what should be your network connectivity between India and the US or anywhere else, right, across the globe? Now, what is the latency? What type of network bandwidth has been published or been given to you to access the systems? So there may be a lot of natural things that can happen in the environment, such as weather conditions and other things, due to which your network capacity or your internet capacity may get disrupted. So how do you handle this? So in case of latencies, especially more latency issues come when you are actually doing a data migration from one cloud to other cloud, or from private cloud, or from your on-prem to your public cloud. So that too, you will be transferring your data for on a very large scale, like terabytes of data has to go. And if there is any disruption happened, then you have to do the entire redo the entire work. So there are ways where you can do it bits and pieces, but still, there is something called a time factor, right, to do the deploy, to do the migrations well. So latency is one thing, and obviously privacy. Privacy is, again, we are talking about security, where whether whether these public clouds can only be a multi-tenant environment, or they can be a single tenant. Most of the public clouds work as a single tenant. Their nature of business is multi-tenant. When I say multi-tenant, they allow a lot of end consumers or businesses, a lot of end businesses to access their data centers. But each and every consumer or a business user, I mean to say organization, has their own boundaries. So they are given their dedicated boundaries so that they don't merge with other boundaries. So that is what is the privacy meant. So obviously, client data is something where how secure you can do with your client data. Client data is again my consumer data. So it can be, again, in terms of the personal information, PII data, businesses, currency, their not currency, in terms of their budgets, and the business dollar value and everything. So the major challenge is what we are that's what we are talking about, is how we can move the data from your legacy or your on-prem, and how you can modernize those legacy applications into the cloud provisioned environments. So this is a big challenge even today in the cloud environments. So what are the industry top initiatives on top cloud initiatives, which include like optimization, migration, automation, and modernization, which I've been talking all along the slides. So this is some of the latest industry trends, you can call it as, where for 59% of the industries are looking at the cost savings, though they are most of the early users of the hyperscalers being public clouds. Now they're coming back. I spoke about something called FinOps, right? So they are coming back and judging on how do we avoid this costs also on the cloud. So do they really want to go back to their own on-premise and give a capital investment capex way of operating, or they want to go with an opex model? So even if they want to stay on the public cloud, where do they need to cut cost? How to optimize those utility usage of those environments, usage of those resources on the cloud? So now 59% of the people are looking at the cost savings as of now. Then another 57% of people who are still not on public cloud, they are planning to move into public cloud, to migrate their entire workloads into the public cloud. So similarly, I will talk in the coming slides. I will talk about what is SaaS, what is IaaS, PaaS, and all. So move more to SaaS. SaaS is something like an software as a service, where you get an end-to-end along with your application component. You don't need to have to build any application of your own. All you need to use that ready-made product, and then fill your data. So everything will be automated, scripts will be there, automated backups or databases, applications, microservices, containers, everything will be built under the SaaS platform. So what percentage of people, or what percent of industries can move towards the SaaS? Similarly, advanced cloud first. So cloud first is, again, we spoke about legacy environments. So all those on-prem and own data center guys want to look into more of a cloud first. They want to move into cloud, and then think of modernizing, or then think of other ways. So legacy, keeping legacy legacy applications and legacy softwares keeping aside, but all the latest developments and all the latest what are the last 10 years, what are the new applications that has been there, or new application developments have been there, new software, new products that has been launched into the market, which are actually working on their on-premise, they want to move into cloud as soon as possible. Then automated policies. Okay, automation, again, you can do a lot of automation. It can be a backup automation, it can be a restore automation, it can be automatic provisioning, scaling, horizontal scaling, vertical scaling. So all those policies. So see why this 36% is very low, because if you enable these automatic policies and your application grows abnormously, and you don't have control on its growth, then how do you maintain? That is where again the FinOps come into picture, where they want to control the cost. So now 36% of the industries are only thinking about automation policy, but still they have a concern on how to reduce cost once you do an completely automation. So there are a lot of bits and bytes or bison, whatever you can we call it as cons and pros. Okay. Similarly, yeah. Now containers is been an de facto factor. Like most of the applications don't want to sit on a one independent server, and they don't want to sit on multiple boxes. They want to sit on one single server. Okay, where you can build the virtualization layer. On top of virtualization, you can build containers. So container, this term container is simple, is just as simple as your cargo containers which you see in the shipyard, right? So these containers basically are a storage component where you put your application components into that boxes, or into that small logical layers built on top of your virtual layer, which is built on top of your physical layer, right? So you can build your containers on directly on the bare metal, or you can build an hyperscale hypervisor. On top of hypervisor, you can still build a container, and these containers you can build n number of containers based on your server capacity. So there is no such limitation. So each container capacity is based on the virtualization capacity that has been assigned. So how do you actually divide this virtualization on a 32? For example, if you have 32 GB RAM and 100 terabyte of data, how do you actually divide the number of virtual machines that has to be built in this particular capacity? So it all depends on what is your application usage. What When I say application usage, how large is your application being going to be built on those virtualization layer, and what is the concurrent volume that you are anticipating on the virtualization layer onto this container, onto this application. So based on that, you can assign the virtual machine with that smaller capacity or larger capacity, and on top of it, you can build the containers for your microservices, where you have a number of applications can sit in those microservices on a single server, or a single virtual machine, or a number of containers on the bare metal. And expansion, again, expansion is something 33% of the business people, business users, industries are now trying to expand towards from the traditional businesses to, it can be a hyper converged hybrid cloud, or it can be only public cloud, or they want to maintain all three clouds. So what type of expansion they want to do? So these are some of the top initiatives in terms of optimization, migration, automation, and modernization in the cloud. So going to the next, so here we'll talk more about the deployment models, more about some of the cloud components, how actually a cloud look like when you actually start to work on. So in the cloud deployment models, we have something called, I was talking about hyperscalers. Hyperscalers are nothing but the AWS, GCP, and Azure, Microsoft Azure. They are more of a public cloud units, where they are publicly available to any. They serve the multi-tenant architecture, so they are publicly available. And the private clouds are something which is it's an independent cloud, where it can be an on-premise, or there are some private cloud provisioners, like we have IBM cloud, or we have our own TCS cloud. where we give a private cloud to a customer, where we give them a dedicated space for him, and he runs his own servers there. And hybrid clouds are something like where you hybrid clouds all or I don't say are, we have multi cloud also. So the difference between hybrid cloud and multi cloud is something like in multi cloud you operate on all the clouds, like it can be public cloud, private cloud, and you still sitting in your data, sitting in your office premise, in your location, you will have access to those all. You are deployed your applications across all these clouds. But hybrid cloud is something like you have your database sitting in your on-premise. You have your entire storage being located in your on-premise, but your application accessibility goes into your public cloud, where you are investing only a small amount of component on your public cloud hyperscalers, where where you most of the control, you will have most of the control on your storage from your on-premise, and your application actually resides in the public cloud. So that is called hybrid clouds. So there are a lot of provisioners like Nutanix, hyper converged infrastructure we call, where they provide their infrastructure into your own on-premise, and they integrate with Azure or AWS or somebody, and they will say you can work from Azure, you can still have access to Azure. Azure maintains all this data for you, but you can still the capacity is still in your hold, in your control, in your data center. So that is what is hybrid cloud. So here is some of the brief definitions of what is private cloud, hybrid cloud. As I told, a cloud computing model which is an enterprise proprietary, basically private cloud means you can have your own on-premise, you can be a owner of yourself, or there are certain private cloud vendors where they will you they will allocate you entire building, or they will allocate you some space into their data centers, and they will make you the owner itself. You will have a lot of proprietary given to you, and so it's more of a single tenant architecture, and more of on-prem, because it's more of an on-prem. It's not, and it may not be virtual. They can do virtualization also, but mostly it's all more physical in layer. There's some of the top vendors like HP, VMware, Dell, IBM, Microsoft, OpenStack, and even TCS also. We have our own private cloud. Then I was talking about about hybrid cloud, which is a computing model that includes a mix of on-prem, private cloud, and third party, which is more of a multi-cloud. And the integration, when you're sharing your services from public cloud and private cloud, that is more of hybrid in nature, where you have your you have your application sitting on public cloud, or you have your application sitting on private cloud, but data sits on public cloud. So that is more of a hybrid in nature. uh, so some of the why do we actually use this concept of hybrid is something called cloud busting. So what do you mean by cloud busting? Now, for example, I have a capacity in my on-prem, or which is assigned to me, which I have in my on-prem, and I have come to an maximum level of my on-prem capacity. Now I don't I, you know, if I have to procure, it takes a lot of a time, because I have to order it can be Dell people or HP people, and they will take the time to come and install their servers. So when such a situation arises, you can immediately see with the hybrid nature of your cloud deployment, you can automatically start to procure the systems from the hybrid from the public provisioner. So then, where you can immediately switch to public cloud and then start working, deploying your latest applications or latest data into their public clouds. So that is something called cloud burst. Means you have reached a maximum capacity, it's bursted out, and then you can immediately switch over to the public cloud, or either way, to use its capacity. Okay, so that is what. Then we have something called public clouds. I was talking about AWS, Azure, and GCP, where they are more of multi-tenant architecture, and they in public cloud, the difference is there also you can procure a system more physical in nature, but for a small enterprise, like if you say, if there is a small startup company, and he doesn't want to invest into a capex model, and he just until he grows his business to some extent. He wants uh, he wants to use the capacity as a pay as you go or on a paper go model. So instead of investing one time investment, you want to go on a monthly basis or a daily basis. So in that cases, you will never know whether you are working on a physical server or logical virtual machine. But the public cloud provisioners will give you in terms of their capacity, in terms of even if you want a one single vCPU server, they will give you. That's how it is. So that is the benefit of going towards a public cloud. Okay. So as we said, the vendors are AWS, Microsoft Azure, and Google GCP. Now IBM and Oracle also, they have some. They are also moving into public cloud for their especially Oracle components. So what is community cloud? So community cloud is also something shared by a group of organizations that has been common purpose. For example, I can take we have something called Tata One for our Tata Enterprise. So all our Tata Enterprise come under the cloud environments come under community cloud, where all our organizations they are in the same cloud and they use the same platform. So we have a common platform for that. So that is one some example where some of the benefits, like cost, multi-tenancy, drawbacks, ownership. Obviously, like TCS can't have a full ownership. It is the entire Tata group holds the ownership, and so now like Tata Steel doesn't may not have, and another one can't have a fully ownership. So such things can happen. Such ownerships and drawbacks are there, and obviously responsibilities, you can say, shared among many member organizations, maybe. Exactly, that's what you're saying. In terms when it comes to ownership of who owns what and all is a concern there, and also security compliances and auditing, security considerations may be some of the concerns, high level concerns. Okay, now coming to the actual core of how the cloud service models looks like. So we in the first slide we saw what is infrastructure. We just mentioned these some of the categories of core cloud service models. So the cloud service model is built of in infrastructure as a service, platform as a service, and software as a service. So I have come up with this small slider where you can see the differentiation between on-prem, infrastructure, platform, and software. So in an on-prem, all this green, you can see all these green tabs, be it application, data, runtime, middleware, OS, everything is owned by the on-prem. Everything is owned by you. If you are an on-prem, if you own your own on-prem, it's owned by you. Nothing is given out to it anybody else. So, but there is this all. It's more of a capital investment. Now, when you come to cloud, on a cloud platform, it can be a private cloud and a hyperscaler. So, infrastructure as a service, when you come to IaaS, where the infrastructure is something, your servers, capacities, storage, other components, okay, virtualization, storage, network, all these things in red will be owned by the service provider, like AWS or anybody. It can be private cloud guys or IBM cloud, and the rest of the green things like application, data, runtime, middleware, it is you have to manage it, because you have to build on top of all they do is the infrastructure as a service will only give you the underlying capacity for your requirement, like servers, virtualization, storage. But the green area like applications, data or databases, middleware components or operation systems, and its maintenance, everything will be done by you. Similarly, in a platform service, something called platform as a service, where it is more like a automated environments developed by the developers, such as a database service, storage as a service, backup as a service, where all this red from runtime, middleware, OS, virtualization service, everything is been provisioned by the service provider, and only application development and the data input will be done by you. So you own the data. Any problem with the data is your responsibility. Any problem with the middleware or OS or virtualization infra is maintained and is maintained by the subscriber, or the sorry, it's maintained by the public provider. And similarly, when you come to software as a service, everything as we told, right? We like, for example, SAP. SAP is more of a software as a service product, and they have their own. They can come with their own product, or even Oracle. If Oracle Cloud you can take, it's more of a software as a service where they have their entire end-to-end applications, Oracle applications, and Oracle hardware and Oracle software is entirely given to you as a service. So all you need to just create a login for you, and you have to start using it. Okay. So I've just mentioned. So how does basically a very block diagram looks like is I have a cloud client. I log into the cloud using my web browser or thin clients or mobile apps. Then initially you access the virtual machine servers. Then in the past platform you have databases, web servers, and some middleware components, tools like the monitoring tools and all those things. And obviously in a SaaS component, be it SAP or emails, virtual desktops, your CRM products, any CRM products, okay, content management, any CRM products are used as a SaaS product. Okay, some additional services which I spoke about, like database as a service, then desktop as a service, storage as a service, information as a service. So I'll just give you an example since I'm more of a database guy. What type of service we build in a database as a service is what we do is we come up with a lot of automation to be done right from procuring of the hardware, procuring of the servers, virtualization on the cloud with the help of IaaS team, and then we automatically deploy database. It can be Oracle, SQL Server, Sybase, MySQL, DB2, any database, and then we also automate, give you an automated software for backups, maintenance, adding users, everything. So that is what is database as a service. So only an application team will just deploy their application somewhere, and they maintain the connectivity between database and application. That's all, and then start using it like that. Then coming to, yeah, so this is I think I have taken almost 55. It's for
Yes, sir.
355, right?
Yes, sir.
So if I'll just go through one last slide, which is just an architecture framework. I'll just take 2 minutes for it. So this is how a cloud deployment in general looks like. This is a very high level where you can see a self-care portal where you manage, and there is, oh, sorry, what happened? Okay, where you can see a self-care portal, then hybrid cloud management and cloud analytics. Basically, this is orchestration done by the cloud subscriber or cloud provider. Sorry, and then this particular will only be given to you. You will log in through this orchestration layer, and underneath this all is the governance, security. All will be maintained by the public cloud or the cloud vendor, and obviously who are the main competitors we are given it. So this is a very high level architecture framework. Okay, so I can stop here, right?
Yes, sir.
Hope
Thank you, sir.
you guys, everybody understood or got what I have said. If I'm being too fast, just let me know.
Dear participants, kindly post your questions in chat window.
So where do I do? Do I see the chat? Shall I stop sharing?
Yeah, sir.
Okay. Okay, I can see here. Okay, if anybody has questions, they can ask. I am not sure. I don't see anything here. And well, thank you, Bytes, for giving me this opportunity. I usually used to go to campuses to give you the technical sessions,
Yes, sir.
but this is the first time of such a large scale, basically, the entire VTU. So thank you very much for giving me this opportunity.
Yes, sir. Someone has asked a question in chat window, sir. Please go through chat window, sir.
I am not seeing where is that? Okay, can we use entire platform as a
Shall I
service?
read, sir? Yeah,
Yeah, yeah. Can we use entire platform as a service for old PCs? What do you mean by old PCs? I mean, you mean say old computers or what is it? I
yeah,
mean,
yeah,
can
yeah,
you
sir. Personal computers.
no, basically platform as a service? See, personal computer is again an independent machine. Inside your personal computer, you can create a virtualization layer where you can develop your platform and you can use it as a platform as a service. Otherwise, you if you want to use platform as a service, you can integrate all your personal computers into one as an underlying hardware, and then you have to build a layer, basically a wrapper or a page, a web page, as I showed you in my last slide, right? That orchestration layer. So that orchestration layer is something where you develop what type of application, like for example, desktop as a service or database as a service, where you build that orchestration layer for automation, for automating all this set of events that you actually do manually. Obviously, you can do if you want to integrate all those pieces and make it as a integrate all to talk to each other. Then under, like for example, if you go to your you have your labs, right? For example, in your colleges, and you if you want to access from one computer to other computer, there is a LAN attached to it, and through LAN you can still access from one machine to other machine using user ID password. So that can happen, but platform as a service is something different. Your PCs can act as a infra, but on your PCs, if you have some applications developed or built on it, that through your platform as a service you can use it. I hope it is clear. I mean, I don't know whether he has
Yes, sir.
understood the. He did.
Yeah, sir. Thank you, sir.
Yeah. Any
Yeah,
other question?
yes, sir. I thank Srihari sir for such an informative session on cloud computing. Now I request Srihari sir to accept virtual memento as token of love and respect.
Okay. Thank you very much, sir. And as I said, it's a privilege for being part of this session. So, do I get this in the mail or how do I
Yeah, yeah,
just
sir. I will
download?
send.
Okay.
I will
Thank
mail
you.
you, sir. Okay, sir.
Okay. Thank you
Thank you.
very much. Thanks. Thanks
Thank
very
you.
much, sir.
Thank you, sir.
So, if anybody needs any, if anybody has any queries, they can write to me, or they can write it to you. You can forward it to me. So, we are